Hello, this is Patrick W. Crawford, Moo-Ack Productions, and this is a demonstration of a game demo I created a couple weeks ago. So, the idea behind this game demo called Mouse Action is to mimic the idea of what the Nintendo Wii or Xbox Kinect does, and taking motion that the user creates and translating it into in-game events. So here, what I'm doing is mapping logical mouse motions into sword motions that the character will respond with. So if I open it up here, this is again one of a couple other projects I've put together to help prepare myself for a future game project I have in mind for myself. That is, of course, going to be a sword game that you'll be seeing more of later on. So now that it's loaded, back up. So, a little more background. Some of the things I worked on in creating this demo are, of course, the idea of mouse tracking, or, taking the input of the mouse motions. But I've also worked heavily on getting the particle system and GLSL shaders, and also a GUI or interactive setup. So here you see there's a couple different tabs that link you to different important things. So this comes up when the game first opens, just giving you a little bit of background. You can see there's a tab for controls you can click on that tells you the different motions that there are. So there's left, right, upwards, circular motions, and the graphics here also kind of give a hint to how it's programmed, so you know how to utilize it best. And then there's also this sensitivity bar that basically increases or changes how easily you can activate a motion. So again, a little insight to the programming. If you put the sensitivity up, basically it's like these center bars here go more towards the center, so that the motion can be activated going over less area of the screen. And for the circular motion, it means that there's a higher threshold to, well, again, your circle can be a little more wiggly, I guess. So that's the main GUI, or interactive GUI. Over here I have a tab just for linking to more of my stuff, such as the Blender artist page where this is located. There'll be a description on this below, so you can download it yourself for free. And the other thing it says here is there's what's called a fireball. So I'll demonstrate that real quickly. Bring that down to 0. This is the spawn rate, pretty self-explanatory. X to close it out. So at 0, nothing will spawn, so we can just experiment with the motions. So, mouse tracking. So first, going over the linear motions, you have a left to right swipe and a right to left swipe. Notice if I go under controls, the sensitivity is all the way down, so if I just move it like here to there, it doesn't do much. But if I bring this all the way up, I only have to go over a little bit of space to make that happen, which can be a bit more convenient, especially if you're working on a larger screen or whatever. So those are the left-right swipes. You have a vertical swipe. Then you also have a circular motion. I would have actually had this video out a couple of weeks ago, or like a week ago, but I was having a lot of difficulty with the circular tracking working at the same time as the linear motions. Sort of works now. Circular still is more sketchy, but that's something to improve on later. It at least somewhat works now. So the idea of this demo is you have a number of different orbs that will be coming in that, well, I'll start it up now. I put the spawn rate above 0. So orbs will start spawning, and I'm going to use the corresponding motions to take them out. So every time you defeat 10 of them, you get another fireball, which is this. You just left click anywhere on the screen to activate them. And then the spawn rate goes up a little bit. So you saw there was at 9. Once you get this 10th one here, you see it's now at 14. So it's gone up 5%. So over time it'll, obviously slowly go over, or you can just do it yourself. And more keep coming at you. Even higher. Let's see how long we can survive here. Not long. Circle. Yeah. Okay, fireball, fireball, fireball. And then there's also golden orbs, which will give you health. And yeah, you just try and survive for as long as you can. And when you fail, then it brings up the more info screen, or linking to other stuff. So that's the basis of the demo. There's really not that much more to see. You notice I have a fancy button. It is enabled. This was, like I said, a test of using particles and filters and whatnot. Click on this. Again, big thanks to SolarLoon, who I'm using his particle emitting script. But if your computer is not able to handle these graphics because there's a number of particles and filters going on, whatever, just click fancy, and it turns it off, and it'll run much faster. So I could restart if I wanted to, or I'll just, click one of these buttons to follow some other stuff, like my YouTube page, whatever. So that's the base of the demo. After this, I will go a little more into the programming of how I set this up for the curious. Otherwise, if you don't want to keep watching, thanks for watching so far. Alright, so I'm back. I've changed the resolution of the screen so things are slightly more visible at 720p now. And so now I'll just go over a bit of the setup of the whole thing. So, the entire game was basically composed of two scenes. This is the main scene. Not pretty simple, it's just our little character in the middle, a couple lights doing the shadows, or other one I guess, shadows, and then these three empties here are the spawning empties. Much of what is controlled is actually by the GUI screen, or the interface scene. So as this is obviously all the elements you see here, it's actually comprised of a number of different planes and textures. Having them all parented together, I can use object color fade to control the transparency and how they appear and or fade out. So I'll first go over a bit of the interface programming, or just the basis of how I've done it. So it's not really about that. So the idea of what I do here is I have one central object that controls all the scripts, which will be this invisible cursor. If I want to create a actual cursor to show on screen instead of your OS's mouse, then I would uncheck make invisible here. But this basically in every frame is updated to the same position XY of the screen as the actual mouse. So this object has a number of properties here, as you can see, and a number of scripts attached to it. Basically, most of the scripts on the GUI screen use the GUI script, of course, just calling different modules. Like here it's calling .click or .health update. And that's kind of the benefit of the module script, is that you can, or modules instead of an internal script, is that you can create different entry points. So, going over this, basically the way that I had the GUI system work is that if there's ever a left click, so that would, there's the left button click, then it activates GUI.click, and that is that's a definition here that basically processes to see is the mouse over an object with the property click. If so, what is the value of this string, of the string of click? And here this property is will define how that object behaves when clicked upon. So for example, on a button, that does not have the property click, so it is not sensed. That's just the texture, but the thing behind it, the actual button, there we go. So it has a property click, so that when it parses through this property, it sees, okay, it has the first part of this string is button, so it will run the button script, which is depressing, or basically UV sliding it so that it looks like it's pressed down. And then the second half of it is when the mouse is let up, then it will activate this string, or rather it sees if it's this string, then it will activate the link for that tab, the Moo-Ack tab actually. And likewise, over here I have these buttons are links. So like for example, this one here, again that's just the texture. Here it is click again. Again, it's a button because it will depress, but then it has the property link. So then it looks at the other property it has, and that is the actual value of the link, the YouTube page in this case. So that's basically how I process clicks in the over screen here. For the slider, it's similar, except instead of button, it's slider, and then this just corresponds to the name of the slider. And then here it has a second property that is the XY, or rather the X minimum and maximum that the slider can go over to. that'd be the endpoints here. So basically that way it doesn't go too far over or in whatever direction. So that's the basis of the GUI screen. Really that way of processing I find to be the most convenient because you have everything consistent and it's literally effortless to create another button that does another thing. So like if I want to create another button that links to some other page, I just have to duplicate or create another plane. I'll duplicate it here and then just change the URL there and it works. Or if I want to create another button that does some other function, it's the same thing. Once you set it up once, you don't have to do it again. That sort of thing. Otherwise, the main thing on this is really just talking back and forth with the other main scene, which I'll go into now. So this is where most of everything happens. On this screen, I have, I believe, the camera holds. Yeah, the camera holds most of the objects. The light source, this one I believe, holds the controls for the fancy aspects of the screen because it holds the filters and whatever. So that's, but again, that is contacted by the camera, this object here, which has everything else. Again, most of it's just messages being sent back and forth, telling what's going on. But the main processes are mouse tracking main, which actually controls a lot more than tracking, but that's sort of the main module. Hence, it has .main. So going into mouse tracking. Again, that's the name of the whole Python script, does a number of things, but what we're looking at now is the main entry, the main module. So when any of these are activated, and these are activated every frame, so this always happens every frame, it will go through this script. Some of this is just kind of a setup. This is a way to make sure that certain things are only done once. The nice thing about a module is that if you globalize the variables, I don't have to import these things every time I run the script. It's already part of the script. So this is just a way to make sure that these things are global variables that stay there. So after that, basically what it does is, for the mouse tracking script, I decided that it didn't need to see or find the position of the mouse on every frame and go through that. So this statement here, it increments the counter of the mouse, and it only will run the tracking analysis if it's every third tick, basically. So every third tick, it also does a script that will randomly spawn orbs at one of these three empties. That's just another definition that I've created down below. Then it goes through, it checks to see that the memory of the frames is not cut off. So I'll go into more of the tracking, because otherwise it's a little too disarrayed. So the way that this is sort of set up is that, again, every 3 ticks it will add the XY pixel coordinates of the mouse to a property called mmem, or mouse memory. It's a string. So the format, if I enlarge this a little bit, the format of the string will be, for example, if it's starting, there, that'll be 1 coordinate. Actually, I think I used commas and then semicolons, because that way it's easier to get the XY coordinates again later. So it'll continually add the set of coordinates for every frame. And I think I've set it so that if there's more than 10, then it will take off the oldest set of coordinates. So it's basically using this as sort of like a cache or a memory for where the mouse has been, so that I can do the analysis to see if a proper motion has been achieved or not. So going down, so the key thing here is that this module that I've created here will define whether or not an action has been completed, and thus send a message such as log.send message left to activate the left motion. So mtrack is where I have basically set everything up. So let me scroll down to that. Mtrack. Here we go. So the input. So basically this is the actual analysis for the tracking. So it takes in several things, such as the already completed list of memory, or the XY coordinates that the mouse has been. the dimensions of the screen, so I don't have to call it here, and the sensitivity. It's a 0 to 1 value. That's the little slider that makes it more or less sensitive, or how much you have to move the mouse to actually activate the actions. So I won't go into the nitty details of how I programmed it, but basically I'll put up a little demonstration image instead. Basically, the way linear tracking works is it looks through the list of coordinates that the mouse has been, and it looks to see that the current position. So okay, for example, for the x-axis or x analysis, as I have here. Ignore this first part. That's just so that it doesn't override the circle data. Here, what it's basically doing is it's seeing if the x coordinate is in a critical zone. So this is the current x coordinate where the mouse is right now. If it's between 0 and the critical x value, as in on the left sort of critical zone of the screen, then it will actually check to see if there's somewhere in the past, in the memory frame, there exists a point that the mouse was in the other side of the critical zone, the other critical zone. And then it goes through, does the reverse. If it's on the right side critical zone, then it checks to the left, and then it does the same thing for the y, or the vertical axis. So that way you're really only checking for 2 points, and as soon as you reach a point, then it just breaks out of the loop and returns the value that, yes, this is a motion has been achieved, and return to the rest of the script to then pass on the message right, or activate this motion. The way I've set up the circular tracking was slightly more complex. I think I actually linked it to a different, I've linked it to a different module that's actually its own thing, or not a different module, a different definition. So that's the definition. This is just an output. It checks to see if it's tracked a certain number of degrees, because the problem with circular tracking going on at the same time as linear tracking is that they can kind of override each other. Like, you have to make a way so that the script doesn't confuse the bottom half of a semicircle to be a left to right track sort of thing. So, but just we'll go over that in a little bit. So circle tracking, that's the definition where I do the circle tracking. This is just commented out ideas that I had for other ways of going about it. You can go about a problem a number of different ways, but this is the way that I found to be most efficient. So, circle tracking. Again, the input is data, the XY coordinates, the minimum radius, and then the threshold, which is another sensitivity-based data point. Again, that 0 to 1 affects that. So, basically what this does is, again, it looks at the current frame, and then it goes backwards through each of the frames in the memory cache. Essentially what it does is it converts things to polar coordinates, and polar coordinates is, as opposed to the XY Cartesian coordinates, it is a way of representing a point with respects to a radius and an angle. So that way I can basically check to see that the angle is always increasing or it's always decreasing. So that's what this does here. It makes sure that the sign direction is always the same. And this part is checking to see that the radius is more or less consistent. That is, it stays within a similar threshold. And those are basically the two parameters that create a circle. So if you ever go outside of this parameter of the threshold, such as if you were doing a left to right swipe, the beginning radius would not be the same as the middle radius. So then it would say, oh, this isn't a circle, back out. The other thing that will break out of saying that no, this isn't a circle is if you ever go backwards a little bit, or you don't continually go in a circle. So in theory, like, just doing that, it's a really simple problem, but you also have some issues with, if you cross over the vertical axis, the way I've gotten the angle to convert to polar coordinates, you need to check to see what quadrant it is, and some various other things to make it a little bit more complicated. But that's the basis of it. So going back up here to linear tracking or the full tracking thing, basically what I was saying before is that the output of the circle tracking data is circle direction. Well, what this is actually either the string clockwise, counterclockwise, or nil. If it's nil, then basically it means no, you have not completed a full circle yet. But then it also outputs this value theta tracked, which that's basically saying how many radians or degrees, I suppose, how much of a circle have you completed so far. So that down here, basically if you've gone enough, well in this case, if you've gone at least 90 degrees of a circle, then it knows not to do the linear tracking because it's looking like, basically it's looking like a circle so far, so we're gonna not activate any linear action by accident. So if you haven't gone 90 degrees yet and it's already a left to right swipe, or if it's nil already, nullified, then it will just go through and do the linear tracking. So again, if circle is true, then it will just wait. If circle is not equal to nil, as in it's one of the circle directions, then it will return the result and engage circle tracking. But if circle is not true, i.e. over here it's not gone enough radians in a consistent direction, then it'll do the linear tracking. So that's the basis of how the tracking was set up. On the Blender artist thread, I posted some comments on how you could achieve some more complex motions. So I'll briefly go over the idea behind those now. So what we sort of have, the way I've set it, you can only really do left to right, top to bottom, that sort of thing, and clockwise or counterclockwise. But theoretically, it's actually somewhat easy to create some more complex motions. So one one setup I thought of is called, or I've called, sector tracking. So that's what this is here. Obviously, you can read through more of this yourself. It's on the link below. But the idea is that each portion of the screen is set to be sort of like a quadrant in the 2D plane, except you have a space in the middle. So you have 9 sectors. So, for example, if I want to make this compatible with the game right now, if I had set up of sector tracking, a left or right swipe, so like this, going left to right, basically the script would say, are you in sectors 1, 4, or 7? And has it gone to sectors 3, 6, or 9? So that basically, if it's gone from that side to that side, then it's activating that motion. But for example, you could also do something more complex, like have you done a diagonal? Have you started in sector 1 and have you gone to sector 9? So you could do motions like that. Or you could do like a V shape, like 1, 8, 3, and checking for things like that. So that, again, would be theoretically possible with this sort of tracking setup. Another way to create more complex motions would be what I call action tracking. The idea behind that is instead of tracking, doing some really complex, have you gone here, then there, then there, then there, and there, whatever, instead it looks at a history of actions that have actually been activated. So an action in this game, the demo you've already seen, would for example be left or circle or up. So it would look at a different property that's set up saying, okay, have you done left, then did you do the action right, then did you do the action left? If so, then the next combo, if it would be up, instead of doing the up action, do the combo super attack option or something. So basically you can sort of synthesize or kind of propagate more complex actions by doing things in order. And those are the most basic ways I thought of creating some pretty complex actions, but already they multiply together, so you can pretty much almost get a fully working game that just depends on how you control the mouse, which I feel has a much more organic feel to how you interact with the game as opposed to just pressing a button all the time. And there's also the factor that, like, quote unquote, you have to have good form, or like there's an actual technique to do it right. You don't just have the guarantee that you always get a perfect sword swipe. So that sort of aspect I actually kind of like, and I'm really happy to see that it actually works in a stable sort of way. Again, circle tracking could be improved upon a bit, but so far it's a pretty functional system setup.
So that's the basis of it. Thank you for watching so far. Again, you can download the demo below. It's in the description. Free to download. It's made with the Blender game engine 2.64. No, 3? 2.62. That's what I was working on it. 2.64 is not out yet. Alright, thanks again, and I'll see you next time. Moo-Ack.